Grab the notes. If you don't have the notes from last session, I have a few spare up here. Come up and grab one. It's this one over here, 15 BC.
Yeah.
Let me grab and just pass it around to whoever's coming. Last session, I did a very quick revision on 15A, but let's do a little bit of a proper one again. Chapter 15, I'm just going to go over here to show you the formula sheet from your exam. This is what you're going to get for your exam for the probability section. Okay? This is what it looks like. Let's break it apart to see what you need to know. First bit, probability of A equals 1 minus PR of A complement. All of this here is your year 10 or year 7 to year 10 probability. Okay, just looking at this section here. So this bit, that's your year 7 to year 10 probability. Yeah, so addition rule, conditional probability, and then you've got the complements. Yeah. Next bit. This is your, which chapter is this now, where you have mean is equal to E of X, and then you've got your theory for variance, your actual data minus the mean, and then squared. I tried to explain to you why we did the, square your data and talk about spread. What chapter is that again? 13. 14 is an example, which is binomial. So it's an example of a discrete. So this is chapter 13 theory. This is just probability theory. So you needed to know, yes, this is from 14. So that's probably where you were saying. So that's your combinations for chapter 14. Then you look at this one now. Can you see how this is summarized? And that's what I was saying. You need to be able to distinguish what problem you're going to get. See, discrete, that's your chapter 13 there. That's a theory I taught you. So I taught you, how do you find the mean? You told me it's the distribution table, X times the probability. That's how do you find the mean, and I showed you the proof to it as well. Then I showed you the logic to what variance was. And I gave the example of, I think it was talking about number of hours you study and then my prediction for whether you get an eta of whatever it is. And I showed you that I could be 30 off, but I could be 30 off positive or 30 off negative. If you don't square it, the net will be obviously something that doesn't tell you the actual data. That's why we square them. If you square them, the problem is it's inflated error. So that's why variance is a measure of spread, but then standard deviation is a measure of spread, but more accurate in terms of units. Yeah? So that was a theory. So that's chapter 13. Chapter 13 is theory. Revision of your year 7 to 10 mathematics, probability. Chapter 14, this is where we're up to. Or we just finished. Chapter 14, notice again, this is the mean, but coming from the theory, that's where they get that. If you look at the appendices of chapter 14, I think it was, or chapter 14D, it will show you the proof for that. You don't need to know the proof, you just need to know binomial. If it's binomial problem, if it's a Bernoulli sequence, n times p will tell you the mean. Variance is np times q, or np times 1 minus p. That only applies if it's binomial, so chapter 14, right? So this is chapter 14 binomial, both of which is discrete. This is discrete general, this is discrete specific. Continuous is different. This is where we started chapter 15. So then I revised with you in our last session. I did a very quick one. And I asked you in the last session, I said, what was the mean from chapter 13 again? Some of you remembered it was X times probability. And that's literally what's happening here. It's still X times. Now, why is it f of X? Well, let's think about it. Why is this? Now, this is one I asked Alex in our last session. Function, integration is the area. Why is, what are we talking about? What is it called when we say the area under a function? If it equals to 1, if the area equals 1, and the function itself is above 0, what do we call that kind of function? What is the name? What's the name again? Because it's key for chapter 15. Good. Probability density function is the key word. So probability density function, PDF. If they ever say that, that means that the area when we represent as a probability, because remember it's continuous data, and I showed you have to do an interval. The intervals is the probability. And if it's the probability, it has to add up to 1 and it's greater than 0. That's why integration of the function between negative infinity to infinity times by x, that's probability, times x gives you the mean. All right? So same thing with this one. Now I did make a mistake in the notes. Go back to your notes again, and hopefully if you didn't fix it, remember I told you variance, the computational rule was E of x squared, take away. What's the computational rule again? Anyone remember? For the variance. E of x squared, take away. Very good. The whole thing, E of x all squared. If you didn't know, it's in the formula as well. They usually give it to you somewhere. Did they give it to you? Yes. Up here. Okay, so E of x squared minus the mean squared is the computational rule for variance. But they didn't give you the one for continuous. I gave it to you in your notes, but I made a mistake just over here. If you haven't fixed it, can you please fix it in your notes? See, I wrote here. Oh, I fixed it. Again, actually, the old ones didn't have it. That was the old one. So the old one, I forgot to put the square. The new one, which I just squeezed in, I just did a screenshot and put it over it. New one, you're missing all of it squared. Because each one, this represents E of x squared is this one. Take away, and that's your mean squared. So that's your E of x all squared. So just fix those notes there. I just didn't put the squared over the entire thing. This is your computational rule for chapter 15. It's an introduction to B and C. Okay, so we're going to do some problems today where you're utilizing the same theory. The only difference is it's continuous data now. So continuous data, if you want to find mean, that's your mean. If you want to find variance, this is the computational calculation for the variance. And then to find the standard deviation, square root whatever that answer is. Okay? So it means that as you're doing chapter 15, B and C, you'll find that your calculus skills, how to antiderive, some questions will get you to do it by hand. Most, you'll probably do it on a CAS. All right? All right, team. Let's do... Oh, there was also one thing as I was going through reflection about last session with 14C, and I mentioned 14C is a really tricky exercise. I said in class that you didn't have to learn to use inverse binom n. You could also do trial and error, but I actually wasn't sure if you guys know how to do trial and error. Have you guys learned how to do trial and error? Hands up if you know how to do trial and error. Hands up if you don't know how to do trial and error. Okay, there's a few. Okay, just a quick one, just for those who don't know. When you're doing 14C, I'm just going to go back to the question 17. Not question 17, question 7 of your textbook. This question, the notorious one. I did this last session where I said, n we don't know, so how many trials? You know success is 0.7. And you're essentially working out from 50 onwards, when x is 50 or more, I want 99% of the time that to be true. You can do inverse normal, which is what I showed you over here, how to do. Right? That's one step. You get it? For those who don't understand how to use the inverse binom, you could trial and error. It takes about 4 to 5 shots, and you'll get it as well. What you can do, since you don't know what n is, you do know what p is 0.7. You do know that you want x to be greater than or 50, and you know that the total probability, you want 0.99 and above. So all you have to do is literally what we just described. From 50 onwards, whatever the data is, I just need this probability to be more than 99%. So if you need that, CDF, cumulative probability, so if you did binom CDF and added them, and you just trial and error, n. So what that means is on my calculator, I'll do something like this. I would do menu, probability, distributions, binom CDF, for those who don't know how to do trial and error. Number of trials, make it up. You could say, well, more than 50 shots, so maybe I'll do 70. Probability of success is 0.7. Lower bound was from 50 onwards. So since I said I'm going to have 70 trials, then it's 5270. So if that's 70, that needs to be 70 as well. So all you're trialing is, what if I did 70 shots? Would that be enough? No, it's only 45%. So then I change it. All I do is I just move up, change the n again, change that to, I don't know, 80. Change that to 80. That's now 94. So I'm getting pretty close. So maybe I'll try, I don't know, 83. 83. 83. What do I want? 99, yeah? So 99, a bit more. So maybe 84. No. 85. Okay, it's got to be 86, surely. 86. All right, yeah, there you go. So, you see, I've just done a couple of shots, but you didn't have to do inverse binomial. You didn't have to do the whole rearrangement. You can do it logically that way. So, for those who don't know how to do trial and error, that's one way to do it. You can do, for that question, you still have to do just this bit. So that's the only part that's algebra. And then from here you can do, because you can't possibly do that by hand. So then No, don't even do that. I'm pretty sure if it's a show that question, then you should be able to do it from here by hand. But if it's something is this large, then it's all casual. So you have to do trial and error when it's a casual. All right, team. Back to 15B and C. That was just something on my reflection as I was thinking about you guys, and I thought, did you know how to do trial and error? And just in case you didn't, that's something to practice. But 14C is not easy. Worthwhile doing. All right, team. Let's do this question. I think I left off around here. Can we change this problem here? I'm just going to delete this because I did the solutions already. I'm just going to delete it. Yeah. Can you cross off that word? It's actually verify. You can't do it with show that unless you know a bit of double angles from specialists. So this is a verify problem. So it's not a show that, it's a verify. So the question says, show that the median is less than pi on 6. What you need to understand is, the first part of the question was find the value of k. You can do this by hand, but you can also do it with a cas. That means, if you think about this graph, no matter what the function is, picture a random function, you're saying between 0 to pi on 2, because it said 0 to pi on 2, they're saying this function, because it's a probability density function, the area must add up to 1. It's clearly above 0. So how do you find k? What I did was I just said, well, let's integrate this, let it equal to 1. So area under the curve equal to 1. And then solve for k. That's how I got k equals 3. Okay, so we got k equals 3 now. Next question. B. Verify. Let's verify. So we're verifying that the median. Now again, let's draw the graph. I'm drawing a random F graph. Doesn't really matter. We're just trying to understand it conceptually. You've got a random F graph, which has sine and cosine in there. It looks scary. Whatever it is, we know the area under the curve is 1. If k equals 3. Now they're asking, can you show or verify that the median when it's between 0 and pi on 2, we know for sure pi on 6. The median is somewhere less than that. Now when you say median, back in year 7 and 8 statistics, what does median mean again? Yeah, it's half. It's literally the middle. So if it's the middle of 1 is 0.5. So what we're saying is, algebraically prove that the area at 0 to pi on 6 is going to be more than half. Because if the median is less than that, it means that at pi on 6, it must be more than 50%. So all you have to do is work out 0, pi and 6 f of x dx. This one has to be more than 50%. Since the entire area is 1 and the median is less than that. So right at pi and 6, that should be more. 0 to pi and 6 should be more. That's why I know the median has to be on the left side. Right? So it's either 50% or less. It can't be more than, it can't be less than 50%. So median. So median, when you say median, we're saying that the area, if it's a median, that means this area has to be 50%. That area has to be 50% to make up 1. So they're asking us, can you verify that the median is less than pi and 6? So if I just worked out the area between 0 to pi and 6, so something 0 to pi and 6 for a function, whatever that area is, if that area, say, was 49%, then that doesn't make sense. That means the median is on the right side. If it's 51%, then I know it's on the left. So we just need to show or verify that this area is going to be bigger than 50%. That way we know the median's on the left side. Because we're trying to say it's less than pi and 6. So for it to be left, that area has to be bigger than 50. So, verifying, we're just needing to show that this is going to be a greater than 0.5. And again, you can sub it in your calculator and solve for that bit. Sub 0 to pi and 6. You already know k is equal to 3. So let's do the problem. I'm just going to delete all this and redefine the function. So menu 1, 1. Define the function is equal to, what is it again? 1 on k, so 1 on 3 times sine of x plus 2 times cos of 2 times x plus 4 divided by pi, given that it is between, what is it? X is between 0 and pi on 2. Here we go, pi on 2. I've defined my function. And we're looking for the area between, so shift right 0 to pi on 6 f of x dx. And we get 5 on 9. The other one, when I did it and I rubbed it off, it was actually the hand method. So you can actually do this hand because it says verify. If it was in a SAT, you should. I'm just showing you theoretically what you do. So from here, you can antiderive sine of x out of curiosity. What's antiderivative sine of x again? Negative cos of x, not positive cos. And then what's the antiderivative of 2 cos of 2x? Very good, because it's 1 over the coefficient of x, so 1 over 2 times 2 cancels out, sine of 2x, and then last one, pi and 4 is, 4 on pi is a constant, so it's just 4 pi on x. So you can do it by hand. I'm just showing you logically. 5 on 9 is the answer. And what does that give you? That's 0.55. So clearly, therefore, median, if that area at the moment is 55%, median must be somewhere before that. So it's less than. Okay, so because it's a verified question, if it's in a SAT, you are meant to show the steps. So just sub in the numbers and then show me the steps along the way. At the moment, I'm trying to get you to understand conceptually. Okay, so just think about the keywords, show versus verify. Flip over the page. Flip over the page. If you've got your cows, can you define the function? Because I want you to answer the next 3. I'm going to delete the answers. Here we go. Let's pause the video. So now you just need to solve it. Correct. So you just need to solve 0 to m dx, and it has to equal to half. Find m. So here we go. Let's type it in. Menu 3, 1. Solve for 0 to m f of x dx, and I want it to equal to, where is it again? Equals to half. Solve for m. Close brackets. And it said decimal places, so it should be 0.4650. Therefore, m, which is where the median will occur, is at 0.4650. 3 decimal places, so 0.465. Hands up if you got that. Good, good, good. Excellent. Now mode. How do we find mode? What do you have to do? Oh, hey, that's true. I just graphed it and then I did it, but that's true. That's true. That's true. I sketched the graph. So mode is... Whoops. Here's your graph. Menu, 4, box. Yes. Your mode is the most frequent data. Sorry? Oh yeah, Control Z. So what you do is, Y12s, thanks. Go to menu, Windows, and I usually use only 2 things. I do zoom fit, zoom box, or I manually fix it. I never use the other ones. So I went to zoom box for the area that I want. So I just selected left corner here, select right corner, and then it's better, yeah. So zoom box, I like using that. Oh yeah? I always use, yeah, I teach my year 11s. I just do zoom box or zoom fit, and then manually fix. Zoom fit is when it's so big that you can't see it. So I get the AI to kind of roughly get it. And then I either, if it happens to get it, but it looks a bit weird, then I zoom box into it. But if it's too weird, then I might adjust the manually myself. So at least I know how wide and how the range and all that. So I only use those 3 to visualize the graph. Yeah. So maximum, yes, that's true. I didn't use the derivative, but that would have been a smart idea actually. I just did the graph. I did maximum. So maximum, remember that tells you x and then probability. Oh, so not probability, the y value of the function. We're looking for the x variable. So the x value, that's when the mode occurs. So the mode occurs at 0.1253, 3 decimal places. There we go. Is that what you guys got to? With the derivative? No, you don't need the 3 because it's 3 decimal places. All right, team. Next question. I want you to try. I'm going to delete these answers so you don't see them. Don't look. Stop looking. There we go. Here we go. I'm going to pause the video.